And we're on. Okay. Obviously the fame got to you too fast. So you've seen the three ratios enough now, okay? Now what we do want to talk about is, oh, that's no fun. This all got moved over. Okay, so remember yesterday, actually it was with the second class, we tried this one triangle that we didn't get the same answers when we did sine of an angle and cos of an angle. And it was because it was a triangle that couldn't exist. Now, sorry, this all got moved, so I'm just going to make it look like yours. Now, when you do sine A, okay, now when you're doing it from here, so everybody see where we are, we're at sine A, this will be my opposite, this is my adjacent, and this is my hypotenuse. So if I'm to do sine A, what is sine A? What over what? Yeah, what are my numbers? 4 centimeters over 5 centimeters. What if I was to do cos from that spot? What would it be? Three centimeters over 5 centimeters. What if I was to do tan from that angle? 4 centimeters over 3 centimeters. Now, everybody get their calculator out. Okay. Now, does everybody understand that I'm doing this all from angle A? So what should we expect? They should all be the same. So some people try sine A, some people pick cos A, and some people pick tan A. And just tell me, as soon as you got it, put up your hand, tell me what you're getting. And tell me which one you did. What'd you do? Let's do it to the nearest tenth. 53.1 degrees. So when you have all three sides, it doesn't matter which one you pick. It's when they give us two sides, then I've got to know what I'm doing. Okay? Now, I think we can expect the same thing if we were going to do C. Okay? If we're going to do sine C, cos C, or tan C, we will get the same thing. Now, without even doing that, can anybody tell me what angle C is? Yes? Good. How'd you get that? Good. So if you go 90 minus 53.1 degrees, you get 36.9 degrees. And if you do any of these, you will get 36.9 degrees. Okay? Now, I thought all triangles add up to 180. Why are we doing 90 minus? Joel? Yeah, 90's already taken. Okay? Yeah, you got it. Now we'll do the other two are always add up to 90. Okay? Or else you could have just went 180 minus 90 minus 53.1, and you would have got the same. Okay? So there should be no secret now of how we're going to do these. The first thing, we want to draw the triangles, if there isn't one. We want to label opposite, adjacent, hypotenuse. That is so the key. If my students are getting it wrong, they label their triangle wrong. That's what happened when I walked around today. Now, determine the trig function you need. That comes if only if 2 is done right. Set up the equation, solve the equation. Okay? So, all we're going to do is we're going to solve 4 questions, and then you're on your own to try the lesson. Okay, so sometimes they just give us, given that angle B is 90, good, that's good, I'm a right angle triangle. AB is 9, and BC is 17. Now, solve the triangle. Like, what does that mean? Solve the triangle. How do you solve a triangle? Like, what does it mean? Get everything else. What are we missing? Missing the hypotenuse. How are we going to find it? Good. So first of all, let's find side AC, right? So yes, Pythagoras is always going to show up. So we will do that doing the square root of 17 centimeters squared plus 9 centimeters squared, right? And when we do that, 19.2 centimeters. Now, we can find angle C by using what? I wouldn't do whatever you want. We just went through that. You said, Mr. Jerome, well, like, if they're all there, I can use them all. Yeah, 19.2, what if it's wrong? You're killing your other ones, right? So, myself, I would use tan theta equals opposite over adjacent. So then you'd go tan theta equals 9 centimeters over 17 centimeters. And you're going to use second tan, right? Because you're finding an angle. And what's theta equal? (27.9 degrees). Now, how can you guarantee 19.2 is right? You've done your test. You could use 19.2 and maybe 17 and see if you get the same angle. If I was doing 17 and 19.2, what ratio would I pick? Cos, good, because that's adjacent over hypotenuse. Okay? Now, give me 2 ways I can get angle A. Okay, who's got one way? I don't want them both. Give me one way. Yes? You could do cos? Okay, why? You could do, if you were doing angle A, hey guys, Joel, just ask later and all. If you were doing angle A, I would still stick to do opposite over adjacent. Now remember, your opposite adjacent changed because they're from a different angle. So for angle A, you could use opposite over adjacent, which is opposite is 17 centimeters over 9 centimeters. So angle A would equal (62.1 degrees). What do I know about these two? I'm going to call this angle C. I should have been more specific. Angle C. So remember, these two should equal 90 degrees. There's so many ways to check to make sure this is right. Right? Checking if your side is right. Now, could you have found the side without Pythagoras? Yeah. Yeah. So you could actually, now you know one angle. I know angle A. I could use adjacent over hypotenuse, right? I could find my 19.2 that way. So there's lots of ways to do these. Okay. Okay. So a 20-meter tower is supported by a 40-meter long, you're right, it's just like the Evel Knievel. Okay. So again, you don't have to be all creative about your tower, but it's 20 meters and is supported by a 40-meter long guy wire. Find the angle of inclination. Remember, you're a tiny small ant in a hole, so this would be your angle of inclination, right? So again, don't rush. These are like guaranteed marks if you take the steps. I am going to label opposite, adjacent, hypotenuse. Therefore, which one should I use? Right, sine theta equals opposite over hypotenuse. Sine theta equals 20 meters over 40 meters. What does theta equal? 30 degrees, good. So therefore, the angle of inclination is 30 degrees. Okay? So you guys could have done this one, obviously without this lesson. Now from a 20-meter fire, or a 20-meter high fire tower is spotted at an angle of depression of 2 degrees. How far is the fire tower from, or how far is the fire? So if you are a tower, okay, and over here you see a fire, a blue fire. Those are the hot ones. Stay away from those ones. So it is going to be like a right angle triangle, and you're looking at the base of the fire in a hole, and this is 20 meters, and an angle of depression of 2 degrees. Now, you are here. Okay? So this is how you see, right? So if it's at 2 degrees, this is going to be not very well done to scale, but this is 2 degrees. Now we want to know how far is the fire. So we're looking for x. Now remember, we can do this. And let's make our own triangle, because this is the same thing. This is x, that's x. And that's 20 meters, right? You got a question, right? You're just resting your arm. So how would I find, what is x? Yeah. So when I go to trig, what is it? This is my adjacent. 20 would be my opposite. So I'm going to use which one? Tan theta equals opposite over adjacent. Tan, start filling stuff in, 2 degrees equals opposite is 20 meters over x. How do I go about solving this? Trade places. X equals 20 meters over tan 2 degrees. To the nearest meter. What are we getting? So the nearest meter. And remember, because it's a word problem, therefore the fire is 573 meters away. How's this looking? Good? A sailor in a boat on the ocean looks towards a cliff. If the angle of elevation is 35 degrees and the cliff is 110 meters high, how far is he from the base? Okay? So this one should be like an insult to your intelligence. So you got a cliff. You got water. You got a boat. Okay? The cliff is 110 meters high. I am looking this way at an angle of elevation of 35 degrees. How far away? Okay, so what am I using? Tan, opposite over adjacent. So tan theta equals opposite over adjacent. Tan 35 degrees equals opposite is 110 meters. Adjacent is my x. These two will switch. Okay, and this one's to one decimal place. X equals 0.1 meters. Yeah. Therefore, the boat is 157.1. We're going to do one more question here, so don't back up here. Meters from cliff, from base of cliff. Okay, so there's one more I want to do with you, because if I don't, then I'll have just maybe tons of people lined up. Okay, so what if we have an isosceles triangle, has a base of 10, and a top angle of 80 degrees. What is the height? Okay, now this one caused a lot of problems with students last year, so that's why this one was pointed out. Got a question or an answer? Okay, well, how would I do it? Okay, but what do we know about an isosceles triangle? Those are equal. We know this is 80. We know this is 10. 80 degrees, I should say. So you want to cut it right in half. Okay, so this is a right triangle. This would be 40. So from 40, it's like I don't have any sides. I got 10, but can I use 10? Right, so this would be 5. And I'm looking for, that's my opposite, good, and I'm looking for the adjacent, very good. Okay, so a few things there that students right from words were like, what? Okay, so top angle of 80, therefore if I cut it right down the middle, I'm going to get a 40 and a 40, and I'm also going to get a 5 and a 5 for my length. So I will use good old tan theta again, right? Opposite over adjacent. Tan 40 degrees equals, opposite is 5 over x. These two will trade. What does x equal? 6? Okay. That is way different than the last teacher got. What did you get? 5. Okay, so we're going for x equals 6. that make sense? Okay. Any questions? Okay. I have a few. Boom. And cut. Cut.